Hello, and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of writing exponential functions. This is standard A.9C in the great state of Texas, and we're using item number 19 of the 2024 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. All right, so we've got some points here. It's going to be an exponential function. So what do we know about exponential functions? Here's our standard form. Y equals a times b to the x power. In this case, our y is going to be g of x. So our a is going to be our initial value. What are we starting with? And then our b is going to be our common factor. So if it is something that is going to end up growing, right, then we call it a growth factor. So if it's greater than 1, we call it a growth factor because it ends up going up. And so you would get a graph and it might look something like this. It goes up when it moves to the right. If it is less than 1, but still greater than 0, we call it a decay factor. So it's a decimal, it's a fraction because it ends up like this. It ends up going down as you move to the right. So we've got each of these, and notice I've only got two options. I've got 32 and 48 is my initial value. Then I've either got 2/3 or 3/2 as my decay factor. All right, so we can solve this with just some logic here. Take a look at my g of x values. It goes from 48 to 72. It increases. 72 to 108 increases. 108 to 162 increases. If it's increasing, that means it's moving up like this. This is going to be something similar to my graph, which means it's a growth factor. So that common factor is going to be greater than 1. Well, if the common factor is greater than 1, I can get rid of a and b because those are decay factors, because those are less than 1. So just by analyzing the g of x values, we can get rid of two answers. Now let's think about our initial value. Well, do we have the initial value? That's the question. Is it 48 or is it something less than 48? Well, let's do simple numbers here. Let's say y equals 10 times, let's say I have a growth factor of 2, right? And let's take it to the 1 power. If I do that, 2 times 1 to the power is just 2, so that becomes 20. So that knocks me off my initial value. That actually grows 1 time. In order for me to get to my initial value, what I would need would be 10 times 2 to the 0. Any number to the 0 power is 1. That's just a strange thing about exponent to the 0 power becomes 1, which means if I have an exponent to the 0 power, then I have my initial value because the growth factor just turns, or decay factor, either one, turns into just 1. Well, this is my x value of 1, which means that is not my initial value. I need an x value of 0. Since this is growing, it's going to be something less than 48, which means I'm really thinking it's going to be this 32, because that 48 is not my initial value. But how do we know for sure? Well, mathematically, this is how you can find the growth factor, right? What you do is you take each value, that's g of x, 162, and you divide it by the previous value, 108. You can take the 108, divide it by its previous value of 72. You can take the 72, divide it by its previous value of 48. They're equivalent fractions. And they all simplify to 3/2. That is your growth factor, which we knew it had to be greater than 1. Now, in order to find x of 0, let's turn this into a decimal so it's a little bit easier, right? We just take this, 48, because it's a ratio here. We're going to divide it by its growth factor. So 48, let's do that, divided by 1.5, and we do get that 32. So that gets us our initial value of 32. So our answer is C.